In this video, we're going to talk about the gradient vector. So let's define the gradient vector, or sometimes just called the gradient of a function f. So let's suppose that our function f depends on two variables, say x and y. The way we're going to write the gradient is like this. The symbol looks like an upside down delta, and when you read that symbol, that's called del. So del f. Okay, so what the gradient is, it's a vector with two components, and in the components we have the partial derivatives of f, so f sub x and f sub y. If f were actually a function of three variables, f of x, y, z, we'd still use the symbol del for our gradient. So you'd either read that del f or you'd just say gradient of f. Now it's going to be a vector with three components. And again, that vector is just going to contain the partial derivatives of f. So f sub x, f sub y, and f sub z. So now that we've seen what the gradient is, let's do an example where we calculate it. So let's find the gradient of f for part A. We've got a function of two variables. So we're going to say del f is equal to, we're going to have two components here, and we're just going to write down our partial derivatives. So first, the partial derivative with respect to x, it's going to be 2x plus y cubed. And then the partial of f with respect to y, that's going to be 3x y squared. So there's our gradient vector. And now we'll do the same thing for part B. This time, f is a function of three variables. We can see x, y, and z all coming up in that definition. So when we write down our gradient vector, there are going to be three components. So first, the partial derivative with respect to x, that's going to be y. Then the partial with respect to y, that's going to be x plus z to the fourth. And then finally, partial derivative of f with respect to z, that's going to be 4y z cubed. We'll be using the gradient vector for a variety of applications throughout the course, and we'll see our first application in the next video. Thanks for watching.